Hello, Andre. So I am here to talk to you about what I have done in my game, the super big collidable group AABB collision stuff with the 4 steps, and then my game plan for the sound system and my game plan for the game in general. So I am going to show you the collisions first. And don't mind, I have a background sound playing, if you can hear it. I'll turn it up. Yeah, so it's playing in the background. So I'll just turn that down a little bit. Alright, so I took off obviously the other camera that was right behind the ship because you said you couldn't see anything. So to actually accurately test the box collision, I'm going to go to these over here. So let's hope. Okay. Okay. So let's get a little closer. Like that. All right. So box. Let's turn it like that. I guess I could just do it from above. It's a little hard to position this. Okay, so actually that's better. All right, so box hitting box, and then the B spheres around all of them show up. I go in and B sphere intersection, and I go a little bit more in. And then box intersection. And I only made it changing on like the cottages, just so then I can tell. So yeah. Those whoopsies are working. Yes. So 1, 2, 3. Alright, so there is the collisions. And obviously we have a collision group with the cottages right there, scaled accordingly, obviously to the biggest max and the biggest min. And then we have the tiger moving over there. Alright, so I guess I could show you exactly what I did with that. So most of what I did, obviously, I did a little bit in the collidable, but not much. I just made a default B sphere, which on each of these, it's going to create a default B sphere, and then in the update collision data, it's going to update the default B sphere's data. That's pretty much was just creating a B sphere around everything. With the actual group AABBs, I went in the collision test pair. So obviously the first one, we had to go through the collection 1, which is obviously the first collidable collection, and we had to find the biggest max and the smallest min to make that overall big AABB for a collision group. And then we do the same, oopsies. Obviously we do the same thing for collision group 2, because we gotta find that. And obviously this is gonna work. If I had put another tiger in, it would work for the, like obviously a tiger group, cottage group, frigate/tank group. So then, in the execute function, we have these min corners and max corners that were set, and then we go through with test 1. Obviously this is for testing the big boxes if they collide. We then go into that, so if they do, they go into this test 2, which is testing to see if the AABB, so the big box, if it's colliding with the B sphere. And then we go in here and it's testing to see if both B spheres of the collidable groups, whatever item that you want to collide with, are colliding. And then finally it goes into the actual test to see if the two collision volumes that you gave it are actually colliding. So obviously that's what you just had seen in the demo. So to speed this up, I'm running at 5 minutes. So I did make a design document which entailed all the details for my sound system, and I also put it in the same doc for the game, which is... Oh, my thing is not moving. Okay. And the game details. So with the sound, I'm going to have a audio class, which is going to have functions like an initialize audio, play sound, stop sound, set a loop. And then I'm also going to be dealing inside that class with setting up channels, which deal with setting pitch, volume. You can pause a channel, unpause a channel, and for each channel there's a sound, or other way around. For each sound that you have, there must be its own channel. So then I'm also going to get into 3D reverb, which is basically setting up these like little spheres of influence in the game, which affects, like, it doesn't affect the audio listener, but the audio listener, obviously, it determines, like, the sound will get louder or softer depending on how far the audio listener is away from that center of the 3D reverb. 2D, 3D sounds, 3D, they have a position in the scene, so you would put that on for, like, the audio sources. 2D would just be, like, background music. Obviously, we have the audio listener right here, which is, what, takes in the sound, puts it through your speakers. And then the audio source is what emits a sound. I'm also going to have a sound asset manager. Actually, I already do have a sound asset manager, but it has a load sound, an unload sound, and a get sound, which I can actually show you right here in the asset manager. So, sound manager, loading. It's basically the same thing that we did with every other asset manager. Pretty simple. Only difference is that obviously the sound hash table node is going to be taking in a int and a string instead of, like, it's specific like a sound typing. And then I have the test for the where is it? There we go. I have the audio class somewhat made. It's also a singleton. Keep it simple. And I'm just testing the audio right now through the test initialize. So down to the game features I'm going to implement. As I was writing this, I was just kind of laughing because I thought it was just absolutely hilarious. Is that it's just a game about you being a tank and you're going around and you're killing tigers to win the game. So I'm going to be having enemy tigers. There's other tanks that are going to try to kill tigers. I'm going to include ammo packs. If you kill or if you destroy a house, it spawns more tigers. Everything you can see is in this document, which is going to be uploaded with the game anyways. So yeah, that's all I have for now. Thanks.